In this video, we're going to look at rational functions, their asymptotes, and the drawing of their graphs. A rational function is a function that contains a fractional part. In this example, the fractional part is 9 divided by x plus 2. The first thing we're going to do is find the vertical asymptote. This is found by looking at the denominator part of the fraction and putting it equal to 0. So in this case, the vertical asymptote, we will put x plus 2 equal to 0 and solve for x. So x equals minus 2. So that is where our vertical asymptote can be found. For the horizontal asymptote, we again look at the fraction, but at this part we look at the numerator. If the numerator does not contain an x component, the horizontal asymptote will be found at y equals 0. Then we look if there has been any vertical shift. There has been a vertical shift here of plus 3, so we must add that. So now our horizontal asymptote will be found at y equals 0 plus 3 is 3. So now we have found both our vertical and horizontal asymptotes. Now we can find both of our intercepts. So the y-intercept, we find that by putting x equal to 0. So we get y equals 9 over 2 plus 3. So y equals 7.5. Now we can find our x-intercept. To find that, we put our function equal to 0. So we get 0 equals 9 over x plus 2 plus 3. We'll now solve for x. So we get minus 3 equals 9 over x plus 2. Multiply through by x plus 2. So we got minus 3 x plus 2 equals 9. Multiply out. So we got minus 3x minus 6 equals 9. Solve for x. So we get x equals minus 5. We can now go and graph our function from all the information we've been given or found out. So let's draw our axes. So let's draw in our first vertical asymptote. X equals minus 2. Our horizontal asymptote at y equals 3. We want our y-intercept at 7.5. And our x-intercept at minus 5. We know that it is a curve that goes up to the asymptotes. So we have got a graph that looks like that. So that is the graph of y equals 9 over x plus 2 plus 3. In this second example, we've got a rational function that has got a linear function on both the numerator and the denominator. But to find the vertical asymptote, exactly the same. Put the denominator equal to 0, so x plus 1 equals 0. Solve for x, so x equals minus 1. So our vertical asymptote is at x equals minus 1. The horizontal asymptote is found slightly differently in this example. So it will be y equals, but now we have to look at the numerator and the denominator and look at their coefficients. So in this case, y is going to equal 2 divided by 1. There is no vertical shift, so we don't have to take that into account. So our horizontal asymptote is y equals 2. Now we can find our y-intercept. That is when x is equal to 0, so we get y equals 2 times 0 plus 4 divided by 0 plus 1. So y equals 4 over 1, which is 4. So that is where our y-intercept is. And to find our x-intercept, we put y equal to 0, so we get 0 equals 2x plus 4 divided by x plus 1. Multiply all terms by x plus 1, so we get 0 equals 2x plus 4. So 2x equals minus 4, so x equals minus 2. So that is our x-intercept. Now we can sketch our graph, so let's draw our axes. Let's put in our asymptotes, so we've got a vertical one at x equals minus 1. We've got a horizontal one at y equals 2. We have got our y-intercept at y equals 4. We have got our x-intercept at x equals minus 2. So our curves go through those points. And that is our graph of y equals 2x plus 4 divided by x plus 1.